Today I wanted to create another video, again covering the System Design Interview book. This time I'll be covering Chapter 8, I believe, Design a Web URL Shortener. And just to explain really fast what a URL shortener is, there's a pretty popular website called tinyurl, and what you can do is, let me pull up Wikipedia right here. You can take the longer URL, or just base URL of a website, paste it in right here, and this page lets you enter in something if you want, or it can just generate one for you by default. So if I copy this, open up a new page, enter, type it in, it'll redirect me to that page. The video for today is going to introduce this topic, how you can make it yourself, potentially host it, and not have to deal with another website or avoid these potential subscription fees. In the book, it talks about back of envelope assumptions. Since this is an interview book, these are things that you should ask your interviewer about in terms of how powerful you need this functionality to be. So in the book, it gives the examples of 100 million URLs generated a day, and that ends up breaking down to 1,157 URLs per second, about. So if you take 100 million divided by 24 hours in a day, divided by 60 for how many minutes, and then divided by 60 again for how many seconds. And it takes the assumption of there will be 10 reads to every write. So for every URL, shortened URL that somebody makes, there will be 10 people that visit that shortened URL. Which means that there will be 11,600 URLs visited per second. Again, these are just estimates. And with the assumption that we're expecting this company, air quotes around company, to run for 10 years, you can expect 100 million writes a day times 365 days times 10 years. You can expect to have to store 365 billion total URLs. So, just to preface the video, some things that you can do to improve this implementation is use an actual database. I'm using an in-memory database just because it's quicker to create the video. But if you plan on using this for any type of production, it is highly recommended you use a database like MySQL, MongoDB, really anything. Just avoid using in-memory database. The other thing is you can use a cache to store the most frequently accessed URLs. To be honest, I'm not too familiar with how to implement a cache. If there's enough interest, I'll make that another video, but at the moment, that's on the viewer to figure out. So, the functionality of this mock app is very simple. I'll go through the post functionality. So, if we go back to the tinyurl, whoops. So if you go back here, this is sending a post request when you enter the URL and then click shorten. And I'll show you here in Postman. So we have the endpoint end with /shorten. Forgive me if these aren't the most RESTful API names. I just kind of took whatever was the first thing working. And as you can see, we'll post this, and it will return to us a shorter URL, with the body being the longer URL that we want to shorten. So we'll remember this in the future when we plan on going somewhere, and I'll kind of walk through the code. So to prevent, again, I'll refresh us. If we're planning on doing, or we're going to end up storing 365 billion total URLs, at maximum, it would be helpful to reduce duplicate writes. One thing that we're doing is we're seeing if, again, it's called map, sorry for the name, it's just a list, an array. But all I'm doing is I'm returning if that value exists in the array. If it does, good, and we don't generate an ID and everything, we just return the short URL. Otherwise, we do a bunch more logic, push it into the array, and return the shorter URL. Now I'll go through this logic here. To generate the ID, I just get the time, get some random offset that I generate, add them together, and return it. I mean, I'm not sure how well this would work in terms of like a distributed system or an actual production environment where you have multiple requests coming in every second. But one thing that you do need to be careful about with generating an ID is, maybe I should show this later, but we end up using a hash of our ID, and one potential pitfall is if you just cut off an existing ID that's generated using perhaps MongoDB. Just focus on the first couple of characters here as I generate new objects. I don't know if you see, but like these first 6 characters aren't changing at all. So if we wanted an ID but only to contain so many characters, it's important that we use something where all the values will change. Why that length even matters? We can do some math here and determine the maximum length of the URL that we need. Because we don't want, the whole purpose of the project is to make a short URL. So we don't want to be taking wikipedia.com/homepage and returning something just as long. We want it to be the shorter the better. And so doing some math, we can do 7 values, and that'll give us 3.5 trillion shortened URLs, which is more than enough for what we were expecting to have of 365 billion, over double. So with this generated ID, we generate a shortened URL by just using a base 62 encoder, and whatever values returned to us, we spit out. Once we have the short value, again, I probably said this earlier, we just return it. The interesting thing is when the user sends a GET request to the shortened URL, we just look at the params body. First thing we do is we do a lookup in case, just to see if that short URL even exists. It's potentially, because potentially it doesn't. I'll save, restart the server. That's okay. So what we're going to do is, if this long URL exists, we'll return the long URL dot long URL, with this being the object name, this being the key. Otherwise, we'll just return false. And if it is false, we'll just return not found, status code 404. Otherwise, we'll return 301. Inside the textbook, it explains use the 301 for faster redirection. If your whole business requires tracking analytics, for example, tinyURL might do this, I'm not sure, it would be best to use a 302. You can see where people click, etc. Again, just doing the same lookup, seeing if that value exists, but this time doing the short URL. If I were to refactor this, it'd be easier just to do map contains URL, pass in either short or long. Anyway, with that walkthrough done, let me reiterate some improvements that could be made. Again, highly recommended to use a database. If you do use memory, you're storing tons and tons of data that you don't really need to, and it will slow down your time. Another improvement that could be done is using a rate limiter to ensure that you don't have bad actors sending multiple requests on your server. Feel free to view my other video on implementing a basic rate limiter using Node.js. And now I'll show off the application. So again, we have this Wikipedia main page. I refreshed the server earlier. Here's the short URL. And if we visit it, it should redirect us to Wikipedia. Bam. Feel free to leave a comment if you have any questions or would like me to go more into depth into things. I'm still working on getting better at making videos. And yeah, thanks for watching.